we'd like to address the inverse square law, both from a patient's point of view and from the staff's point of view. So as you all know, with the inverse square law, we have a point source, and for us the point source is the X-ray. The further that you get from the point, the more the beam spreads. So if you double the amount of distance from the point, then you're going to get the beam spreading over 4 times as much area. So what does this mean for the patient? Well, when you're using the II, let's say you're in the RNF room, the tube's going to stay the same, so you don't have to worry about that. But the image intensifier sometimes has a way of floating up away from the patient. And when that happens, because of the inverse square law, say you double your distance, you will have to quadruple, or you will quadruple, the amount of radiation that the machine is emitting and the patient's having to have in their body. So we want to try to keep that II as close to the patient as possible to keep the dose down. So as far as the staff is concerned, we can use the inverse square law to our advantage, because just like before, as you get twice as far away, you're increasing, in this case, you're going to be increasing the size of the beam 4 times as much. So what happens is you decrease the intensity to 1/4 of what it was. So the further you can get away from the primary radiation, the better you'll be as far as scatter. You'll get less and less exponentially as you go from 2 feet away from the table, 4 feet, etc. So you want to get back as far as you can whenever you possibly can. And whoever is operating it wants to keep the II, or the image receptor, as close to the patient as possible. The bottom line with the inverse square law, with the radiation, is as you double the distance, it has to cover 4 times the area, so it decreases to 1/4 of what it originally was. So for the patient, they'll get 4 times the dose if you take that II up too high, if you double the distance of the II from the patient. But with the staff, as you are able to get 2 times the distance away from the source, you will decrease your scatter radiation dose markedly.